In our last lecture, we discussed about moment of a force about a point. In this lecture, we will discuss moment of a force about an axis. Before entering into the concept, let us understand something about the scalar product of two vectors, because this concept is being used in the discussion of moment of a force about an axis. Let us take two vectors with an inclination theta, then the dot product is pq cos theta and it is a scalar. You know this. Scalar product of two vectors is commutative, distributive, and it is not associative. So as rectangular components, we can have the dot products as this, because you know this very well. And if both the vectors are p, then we have p square. Let us now understand some of the applications. First one is angle formed by two given vectors. To find out the inclination between the two vectors, as you apply and see, you get this value. Now, projection of a vector on a given axis. P is the vector and we project that to this axis OL. So the projection of P vector equals P cos theta. And you know the projection POL is equal in absolute value to the length of the segment OA. So this is the absolute value of the projection of P vector. Just in that axis, if you have another vector Q, then you have the projection of P on this axis OL is this. And when the vector selected along OL is a unit vector, in place of Q vector, if you use lambda vector or the unit vector, or this axis, the vector is lambda, then the projection of P on OL is P dot lambda vector, and that leads to this value, as this magnitude is 1 and the inclination of lambda is cos theta x, cos theta y, and cos theta z. When you have two vectors and the third vector s, and P and Q vectors are in a plane, you know already the direction of these two vectors which are lying on a same plane is P vector cross Q vector. When we deal with these two vectors, we get mixed triple product, and this is being used for the concept of moment about an axis. So expanding this and simplifying it, or writing in a manner, S vector dot P cross Q gives the determinant of S vector, the rectangular components P vector and Q vector, leads to a scalar value. Now coming to the moment of a force about a given axis, a scalar analysis. Let us just see this force. There is a nut to tighten the wheel on the vehicle. The force is applied in this direction, and moment about O is given here. So moment about O is force into perpendicular distance, and this vector and this vector lying on the same plane, then the direction of the moment is perpendicular to that plane, and this is the moment direction. But in this case, the nut is tightened with respect to this axis. So moment about y-axis is given by force into this distance, the distance from F to the y-axis, that is dy. Okay, that is given here. In general, what we can write is moment about any axis A. So moment about any axis A is written as force into the distance between the force and to the axis. We write in a vector form, a general expression. You see, this is the position vector and this is a force vector in space, and the position vector and force vector lying on the same plane, and the perpendicular to that is the moment vector, and you want to obtain a value moment about this axis. So this moment has to be projected to this axis, and that axis has the unit vector lambda, the inclination can be obtained. So projection of that, we use mixed triple dot product, and this moment is nothing but r vector cross f vector, and lambda vector is the axis on which this moment has to be projected. So moment about OL, moment about this axis, can be obtained by the determinant, lambda vector, position vector, and force vector. So this gives the position of the force. So this is the position of the force and the components of the force, and this is the information about the lambda vector. What is lambda x? It is nothing but cos theta x. Lambda y, cos theta y. Lambda z, cos theta z. So this is the general expression. For this case, if we have to write in terms of vector, and this is the j vector, because in this direction the unit vector is lambda vector. Okay, so then when we write, okay, this will have the value 1 because the axis, the inclination between the lambda axis and the corresponding y axis is 0. So cos 0 is 1. This will go to 0. It will have the value 1, and the corresponding these values, if you apply, we will get moment about y-axis. Force parallel to the axis will not produce moment about that axis. We'll discuss in detail in a minute. Now we'll try to solve this problem. You see, there are some pipelines given. Determine the moment MAB produced by the force F in figure, which tends to rotate the rod about the AB axis. So this force rotating about this axis. Okay, in this diagram, this is given as x-axis, this is given as y-axis, and this is given as z-axis. So you have the force vector, and then position vector we can write based on the distances given here, and this is the lambda vector. You have to find out lambda vector corresponding to the axis. In this case, the general moment direction is about y-axis, and projection of that to this AB axis will give you this value. Let us now solve this problem.
Before solving the problem, first let us understand the moment about an axis. See, if this is the axis and this is the force, okay, the direction of the force is parallel to the axis. In this case, there will not be any moment. About a point, if this is the point, there will be moment. But about an axis, there will not be a moment. You need to understand that. Now, if this is the axis, this will produce a moment. This will produce a moment. This will not produce a moment. If this is the force and the distance between the force and the axis is 0, that means if this is the force and this is the axis, there will not be moment. So you need to understand this when you are finding out moment about an axis. Now we will solve this problem. What we need to find? We need to find the moment about this axis. There's a tube, okay, where the force is parallel to z axis, and we have this tube AB. About this, we need to find out the moment. So moment of the force about AB. Okay, so we know MAB. So as we discussed, we have to use lambda x, lambda y, lambda z, then the coordinates of the force or the position vector, and then fx, fy, fz determinant. Okay, now we need to substitute the values there. So first, what is lambda x? Lambda x is nothing but cos theta x. Lambda y is cos theta y. This is cos theta z. Okay. Now, where is the lambda vector? Lambda vector is in that axis. So what is lambda vector? This is lambda vector. Okay. So the inclination of lambda vector is this theta x. So cos theta x, if you substitute here, we get lambda x. So we'll find out cos theta x. So we see this, the length of AB, because this is 0.4, this is 0.2. So we get 0.447 meter as the length AB. So we found out this value, and now cos theta x adjacent by hypotenuse, so 0.4 by 0.447, we get this value as cos theta x, and cos theta y 0.2 divided by 0.447. So we obtain cos theta x, cos theta y from the triangle. So we substitute that 0.895, 0.447. What about cos theta z? So the angle between z axis and AB, since AB is lying in xy plane, the angle between the z axis and AB is 90 degrees, so it is 0. Cos 90 is 0. Now, what is this? This is about lambda vector. This is the position vector, or you can say the position of the force vector. So x distance, this is the x axis, so x distance is 0.6 meter. Y distance is 0. Z distance is 0.3. Okay. And the components of force vector, Fx is 0, Fy is also 0, Fz direction, it is downward, so minus 300. Okay. Now find the determinant. This will be 0, so minus 4.447 into 0.6 into minus Find out 80.5 Newton meter. So it is a scalar value. Okay. So for this AB, about AB, this force is producing 80.5 Newton meter.
Now let us discuss this problem where a lid ABCD of a storage bin is hinged alongside AB. So here it is hinged, it's a box, can open this side BC, okay, and it is hanging with a string. It's a single string, frictionless string, okay, on a frictionless hook E. If the tension in the cord, since it is a single string, everywhere the magnitude is the same, 66 Newton. Determine the moment about each of the coordinate axes of the force exerted by the cord at D. So what we need to first find out? The force vector. The D coordinate is known, E coordinate is known, so we'll be able to find this vector, this force vector, and then we can find out the moment about each of the axes.
From the diagram, we understand the point D, the coordinate of the point D is 0, 0.11, 0.61. You can refer the diagram. Point E is 0.3, 0.71, 0. Okay, and the string is pulled from D. Okay, and the force that is acting in D. So this happens to be our x1, y1, z1, and this is x2, y2, z2. What we need to first find? We have to find the force vector. So DE is the string on which the force is acting. The point of application of the force is D. So the force vector DE is, the magnitude is given as 66 Newton and lambda DE vector. So this lambda DE vector is dx I vector plus dy j vector plus dz k vector. The x distance, y distance and z distance by the distance d. It is nothing but dx square plus dy square plus dz square. What is dx? It is x2 minus x1, y2 minus y1. This is z2 minus z1. Okay, this is x2 minus x1. So dx is 0.3, dy is 0.71 minus 0.11, it is 0.6, and this is minus 0.61. And this, if you are substituting 0.3 square plus 0.6 square plus 0.61 square under root will be 0.9067. So what is the force vector? Force vector E is 0.3 66, 0.3 I vector, 0.6 j vector minus 0.61 k vector divided by 9067. So if you multiply, you get 21.87 I vector plus 43.68 j vector minus 44.4 k vector. You find small difference in decimals, it's not a problem, you solve it. Okay, this is f vector. Now what we need to find? Moment components we need to find. Okay, so moment about point A we need to find. Moment about A vector is I vector, j vector, k vector, and the coordinate of the force is y distance and z distance. Then this component force 21.87, 43.68 minus 44.4. Find the determinant. Finding this cross multiplication I vector 0.11 into minus 44.4 minus 43.68 into 0.61 minus j vector, this is 0 and this is 0 minus 21.87 into 0.61 plus k vector, this is 0 and again it is minus 21.87 into 0.11. So the value is minus 31.52 I vector. Small difference in the slide value, it is due to calculation, you correct it. Plus 13.34 j vector minus 2.4 k vector. Okay. Now this is mx vector, this is my vector, this is mz vector. So the value of mx then is 31.52 Newton meter. The value is, so this is the vector and now only the value my value is 13.34 Newton meter. This is 2.4 minus Newton meter. We can obtain like this. If we have to project this MA about an axis, okay, directly we can get the axis, individual axis. So we need to find three determinants. How to find? About mx, okay, mx directly. About mx means the lambda is passing through x-axis. If the lambda is passing through x-axis, the angle between the lambda and the axis is 0. So cos 0 is 1, 0, 0. They will have the same because this is the coordinate of the force and this is the force component. So 21.87, 43.68 minus 44.4 determinant. If you find this, you will exactly get this value, that is nothing but this value. So directly the scalar you can obtain. So similarly for my, 0, 1, 0, the same values, 0, 0.11, 0.6, 1 and then 21.87, 43.68 and minus 44.4. So you will get this value. So directly this value. So about an axis, if only one axis is asked, find out moment of this force about z axis or the z axis. So directly you can use only mz. You can directly find mz. You don't have to find this way. Since in this problem it is asked mx, my and mz about the coordinate axis. Is it clear?
Lastly, in this concept, the axis need not be always passing through the coordinate axis. There is a force and you have another axis which is not passing through O, then the position vector is this. So with reference to O, what is this vector? RB vector or AB vector will lead to RA vector. So we can find out the difference of x value, difference of y value, difference of z value between A and B. That is given here. That is the only difference. So accordingly, we should be able to find out the moment of a force about an axis. So more forces are given. You can also find for each force what is the moment about a given axis. I hope you would have understood this concept, moment of a force about an axis. Thank you.